Okay, hi all. I'll be presenting quite shortly about presentation events, what they are and how we use them and what problem they try to solve. So quickly, first of all, who I am. I work at LeanCode as a senior developer, and I'm quite connected with the academic and industry world. And I've been doing Flutter and Dart since 2020. And today I'll be presenting about presentation events, and mainly I really want to make sure that you understand what problem they solve. So it's not something that we try to create a problem out of nowhere and then solve it. It's something that actually bothers us quite a bit. So at LeanCode we use BLoCs a lot, which I assume many of you do as well, but we'll go through BLoCs in a moment as well. So first of all, I want to analyze the structure of BLoCs, so how they look and what they do, and then highlight an issue that they have that cannot be really solved in a good way, and finally just build a solution for it, a minimal solution, hopefully. So what is a BLoC? Probably most of you know, but let's go through the main interface of BLoC, which is block base. So it's used both for qubits and for blocks. And it has a few important properties and a few less important. So the main one is the stream. So the stream is where we push new state, and new state gets propagated, and we get updated UIs. And then we have a getter, which is the state getter. And what it actually just does is remembers the last existing state, and then just keeps it alive if we need to access it later. So this is not an event-based approach. We are just, we have a stream, but we also remember what happened last. Finally, we have emit, which is just a way to add to the stream, and then the whole magic of BLoC should work, meaning the state should now point to the newest state. We also have onChange, which just listens to changes that happen, and then you can react to them. And we also have errors, which not many people use, and they're not that useful here anyway. And just a close method for cleanups. The main thing that I want to point out is that BLoCs are change-based or change-focused. So for example, the onChange callback, which we saw just now, accept this class change. And change state holds only the current state and the previous state. So it expects us to kind of diff those states somehow. And then when we have in the UI some block listener, so if you create a block listener in Flutter, you'll have such a callback, which gives you the context and the state. And it gives you only the most current state. And in a moment, we'll notice why this is problematic. So the problem is that now, let's say you are creating an auction, and the auction stores some state, so let's say a title, description, price, image, whatever. But then you realize that you want to implement the bid method. Bid method should just, given a price, increase the price of the auction, and then just propagate it everywhere. But what if the bidding fails? So what you would usually do in BLoC is have maybe a separate state that holds the error state, and then whenever you fail to bid, you should transition into the error state. However, here it's a bit different, because whenever we fail to bid, we don't want to lose all the information about what was the title, what was the description, what was the current price. We still want to remember that, but we still want to be able to inform somehow the UI that we had an error. So here we have, let's say, failed bid error. And let's say we want to encode it somehow in our state. So one approach would be like here, visible. We just store an extra field that is nullable. So we assume whenever it's null, then nothing happened. But if it's not null, that means there was an error and we should be showing, let's say, a snug bar somewhere on the screen. But there's a problem with this. The main problem is that whenever we now emit a new state, we should remember to clear this failed bid error, because we already showed the snug bar for it. So we want to make sure that we won't be showing the snug bar multiple times for one error that happened. So whenever we emit a new state, we should remember to clean this failed bid error field. Another approach, which I've seen also going around, is when you have your separate states for ready and failing, for a failed state and a ready state. And I assume these are in a union type that will be of your qubit. What we could do is in the error state, we would also store the ready state. So if we go into the error state, we still remember everything that happened in the ready state. So we can still show the UI as we wish. And again, now the problem is quite different. Now the problem is that whenever you build the UI, you need to remember that you should actually also take into account that an error state should be still showing some UI and not just showing an error, which kind of defeats the purpose of the name of the state itself. But maybe there's a second approach, which I've also seen people try to do, is, for example, in a BLoC listener, we get such a field as listen when, which allows us to steer when we want to listen to an event. So let's say we have a BLoC listener, and in the listener, what we actually want to do is show a snack bar whenever failed bit is set, which means it's not null. But we also want to prevent the situation where we show the snack bar twice for the same error. So what we can do is, for example, have a listen when that says, okay, if this field actually changes, only then should you run the listener. But this is actually wrong. The issue here is, what if you actually did emit a failed bit error twice in a single run, and you want to show the snack bar twice? Here, the listener would say, okay, you have the same error, so I shouldn't be running the listener again. So you show the snack bar only once. And what's even worse is that if we go back, and if we want to emit the state of fail bit error that is with the exact same message, we cannot do that. Because in BLoCs, the default way to compare state is to use equality. So if two states will be equal, it will not emit a new state. So you are unable completely to emit the same state twice, even though you would like to show the same error twice in a row. So the fundamental issue here is that there's not really a good way to represent one-time events. Because BLoC focuses more on persisting state, the idea is that everything should be read whenever you need it. But what we really want to model here is a way to say, okay, something happened, and let's react to it and then completely forget about it. So this is a solution. This is not the solution. This is something that we at LeanCode, we just did, and we use it, and it's quite useful. But please do not think this is the only way to solve this problem. The most important part is, what is the problem? And now our solution here is very simple, although I'm pretty sure some BLoC purists would say this is completely illegal and should be removed. But I think it's fine. So what we do is just add a mixin that allows us to have one extra stream. The stream will not have a getter like state did. It will be just a stream. So if you want to listen to something, you will listen to it. If you miss it, booyah, you missed it, and that's it. So we have a stream, we have a presentation, and the only difference is that you have an emit presentation instead of emit, and then you use the stream as you wish, as you would normally with BLoC. And we call these presentation events because usually they're there to indicate that something happened, but we don't actually care about persisting that this thing happened. So this stream is non-buffered, so you can only react in that specific time. And we use it quite extensively at LeanCode for just different use cases, because once we realize that such a problem exists, it's very easy to see that this solution actually is very useful. I'm not here to advertise a package. I think the best way is to just write it yourself, because like you saw, this mixin was quite literally copied from the package that we use. And this is a package that is super simple. It does literally just the mixin plus the listener, and it's in V1, and we don't plan to ever enhance it at all. There's also like a testing package that allows you to test things easier, but that's not that important. Okay, and I want to show you this package. Let's see. Is it large enough? In the back, can you see? No. Yes? Yes, perfect. Okay, so this is the auction that I talked about, but now we'll go through refactoring something that used the state to try to represent the error that is transient, but now we'll just move it to the presentation. So quickly, just to analyze what's happening here, we have a qubit, and all it does is just emit some hard-coded state for our auction. Maybe let's run the app in the meantime. And whenever we want to bid, here we just assume that we bid more, which is fixed by 10. So whenever we bid, we just will increase the price by 10. And the first issue we can see here is that, let's say we have a chance of failing for whatever reason. So we would like to here emit the presentation event, because currently what we do is we emit the state. However, we copy over the failed bid error with our new message. And again, here the error that is not visible is that if we emit the same state twice, it will not actually be emitted, because it will not diff as a different state. So we'll refactor that in a moment. But if we don't fail, then we can emit the new state. But here is, again, the second problem, that we cannot really use copy with, at least not the one I use, because this is a manually implemented copy with for our state. We cannot use it because we should be able to set failed bid error to null, but copy with doesn't allow us to do that, because here we use nulls to represent please don't copy this field, which is not really what we want here. So here, that's why manually we have to copy over every field. But if you use something like freeze, this would be given to you, or copy with extension. Okay, so let's start refactoring that. It should be very simple. First thing we want to do is, let's first extend or mix in the BLoC presentation. So we would take with, and it accepts two states, or two parameters, or one, two. Yeah, first one is the state itself, which is exactly the same you would have for the qubit. And then the state, the type of the presentation events. Oops. Which in our case, we actually have only one state, which is the auction failed bid event. Sorry, event, not state. We differentiate state event. Event just means that it is one time and not persisted. So that would be it, and that gives us exactly what I showed in the slide. This is exactly the same code. And now when we go here, the only thing we change is that we actually want to emit the presentation, but now we need to just emit the presentation event, which was auction failed bid event with the error. Okay, that's done. And now here, we actually now can use the copy with, because we don't care about the error that will be in the state. Here we can do copy with, and these don't matter anymore. And now when you go to the state, we can remove this part completely, so we won't be using it. And if you see that the presentation event itself is just a class that stores a single field representing our failed event. And that's it. And now if we go to main, we want to change the listener itself. So before, maybe let's show the app now. So the app is just a single auction that allows us to bid more. And whenever we bid, it either fails, now I broke the app because I refactored the code. But it should increase the number or show a snack bar that it failed. So here, let's now see how that looks. We have a BLoC listener, and we do, okay, whenever the state has set this error, then we are able to show it, and we're fine. But we want to change this. So the only thing we'll be changing is we want the BLoC presentation listener. And now here, instead of the state, I think it's auction. What's the one? Yes. No. This. Here we want the qubit type, which is auction qubit. And you can see the API is very symmetric. I don't have to change either BLoC or listener because this will be the same. However, here we don't actually have the state. We have the event. In our case, since the type of the event is only this, we know that the event can only represent the event of failing to bid. But of course, if you were to use a union type here, then you could just represent a different kind of errors. So here, the difference would be now we can reference the error, event, and error. But now, one thing that is even better is that we actually don't have to compare with null, because we know that whenever we got this event, that means we are supposed to be showing the error. So we can actually even remove the conditional and just do the event error. And the rest stays exactly the same. We can now remove the fix me. Now let's see if I broke anything. Yes, so it goes up, but it's not showing the snug bar. I was told to not do live demos. Yay, okay. So now it shows an error, and either an error or increase the price. And now you can see we actually showed there 3 times. And if I were smart enough to show the state before, it wouldn't show it 3 times because we would emit the same state 3 times, and it would not react to it because it would be the same state. But in this case, we are able to show there multiple times, and the price goes up if we succeeded. So that's it. So as you can see, the solution to the problem is very simple and not really over-engineered. And that's it. And if you would like to try this presentation event thing, at our booth, we have prepared basically exactly the same challenge that I showed just now to get a feel of what we're actually doing. And that's it. And I really hope that you at least understood what the problem we're solving, not the solution itself. And that's it. Thank you.